Yes. We have one half of our senior sweethearts. Ready? And now, next up, we have our Mr. Olympia, who is Joshua. And our Miss Olympia.
No, I'm gonna do. I was gonna.
I thought you guys were together. This is me too. Oh. You have to, yeah, point to it. And you're proud. Over here. You think Russian girls are proud?
Yay!
Probably wasn't happy about it.
We'll have all of you guys take a picture with the Titans, and then we'll just have Mr. and Mrs. Olympia take a picture.
You want your last
So, good thing is, you like each other. We can all
That
make
hat. On me.
Oh.
I didn't really think it was
Perfect. Right? All right, now Mr. and Mrs. Olympia.
So we need the sweethearts together. Nice for that. Mr. Yay, you're.
Hey, David, put your arm
No problem.
You got a city hat. Josh, can you wear your city hat? No, can you wear it?
All right, so we're gonna move on. All right, so today's notes is kind of hard to understand because there was a lot of conceptual thinking. So I know like you guys gonna help each other out, especially like Armin, Ethan, and or whatever. I need you guys just direct the question towards me instead of like I have to focus. I cannot talk over you guys when you guys are talking. So last period I have a lot of struggle in trying to talk to you guys while you guys are talking to each other, and that's gonna be the main issue that we're gonna have. So you have questions, just raise your hand. I'll answer your question the best ability as I can. Now, second things that you need to understand, today is really hard to understanding. Please go back, review the notes before you look at the homework. I know this homework is a lot. You guys have a lot of things on the things. So this homework is 2 days. So tomorrow in class and today. So you're gonna do as much as you can and do tomorrow in class. Is that okay? Okay. So, but this is very, very important, like for you to understand. So again, like I really prefer you guys to watch, look at your notes, even the old notes, like how do you prove monotonic? How do you do telescope series? How do you do geometric series? How do you do, today we're gonna talk n-term derivative, n-term integration test. We already learned how to change from the decimals to repeating decimal to fractions. We did that yesterday. So we're going to continuous talk about 9.2, which is we are talking about in this case is infinite series. So let's talk about some property for starting. That there is a property like this. If you have a summation of a to the n and the summation of b to the n, if they both converge, okay, both converge because some question require this, And if we know summation of a to the n is equal to the constant a, or summation of b to the n is constant b, therefore those three property that you need to understand is summation of infinity n equal to 1, c a to the n. Now again, anytime you have a c as constant, with a derivative integration, they can be always taken outside, and that's going to be c. So this c can be outside here, and that'll be summation of n equals 1 to infinity of a to the n. We know that's a according to definitions, so we can say c times a. 2. If you have summation of n equal to 1, infinity of a to the n plus b to the n is equal to a plus b. Claire, I know you did that, but that's okay.
She's psychic.
I saw you, and I knew that's gonna happen.
You could have like said something else.
Huh?
You could have like said Misha.
What?
Yeah, but that's okay. Rylan, can you pick that up, please? N equal to 1, infinity, am minus b to the n. No, I was gonna say something. I was like, it's probably not gonna happen next period, but happened earlier than I thought. Okay, so this is basically three property here.
Fucking asshole. Maybe our respected elder do it.
Respected elder. How do you get your head chopped off?
Yeah,
You
do
have
it.
to old.
That's how my mom respected elders. I know. Elder died shock. She would kill me.
I can call myself that, but y'all like different. I call you that.
All right.
And
So let's review a little bit. Geometric series, right? We already talked about telescope. Telescope is usually converged to number. Geometric series can be diverge. When's the geometric series diverge? When is what? So remember, this is a n equal to 1, infinity a to the r to the m minus 1. This one, when r is greater than 1, this diverge, right? When r is between -1 and 1, this converge. Converge into the value. So we know that this test can be tell, is a series going to diverge or converge depends on the r value. And that's very, very important that we know that this particular series can go either converge or diverge. But we're going to talk about the next thing. Yes?
oh, I can't R be like. Oh, never mind. I was gonna say, why can't R be less than negative?
There will be diverge also. So let's just do this one. How about that? Like if it's absolute value r is greater than 1, it diverge. Actually greater than equal to 1. So is this okay? Now, there is a particular test, and this test only tests for diverge. It does not test for converge. I'm going to say that again. It only tests for diverge. So I'm going to write down a couple of statements. So this one's very easy to understand. So, but you had to think about it a little bit longer. So this is known as the nth term divergence test. Test for divergence. So nth term test for divergence, or it called it divergence test. Okay, so we know it's divergence test. Okay, so Now, what's the divergence test says? If limits as n approach infinity of a to the n equal to 0, then
What is 0?
does not equal to 0. Then summation n equal to 1 to infinity a to the n diverge. Okay, diverges. Okay, let's just think about this statement. Like, think about it a little bit longer. Why do you think it's true? Yes.
Because if limit n approaches infinity keeps getting bigger and bigger, that means the area on the curve is just going to keep getting bigger and bigger. If it keeps getting smaller and smaller, it's just going to keep going to infinity. Either way. If you add all the
Well, your first statement's good. Your second statement says if it's decreasing, what happened?
decreasing, it depends, because if it goes to negative, it decreases negatively. Then you'll still be going to negative infinity, so it's diverged in all values. If it decreases to 0, then it's converged.
Okay, so there is something that I'm gonna break down a little bit what he said. He says increasing. So let's just say if this sequence, right? If this sequence is not equal to 0, so if it's not equal to 0, it must get bigger and bigger, right? It's not going plateau into 0. So if plateau into some number, it's getting bigger. So if you're adding out all the term, it must diverge. I also like what Joshua was saying is area under the curve, because we're going to talk about area under the curve a lot. Because we talked about integral, and that's how integral related to sequence and series, and that's how they work. But what he say is not correct on one specific point, which is also a major misunderstanding. So people assume if this statement, if limit n approach infinity a to the n does not equal to 0, then summation a to n diverge, and they using this statement, they assume if limit n approach infinity a n is equal to 0, then summations converge. We never say that. I never say that, at least. So what I'm trying to say is this. This is a bad statement. This is fake news right here, okay? So I'm going to talk about fake news. Fake news. Which is, this is not true. Limits as n approach infinity of a to n equal to 0, then the series of n equal to 1 summation a n converges. This is bad. This is no good. Okay, this is no good. The reason why is this. This particular statement is only test for divergence. That's why they name it divergence test. Specifically only toward divergence, not converge. So if you limit n approach infinity a n equal to 0, does that mean converge? It may, but it may not. Okay, it may, but it may not. It may converge, it might not converge. But we don't care about that. We care about, hey, this has to be the truth for real all the time. So that's why the name is called divergence test. It's not test for convergency, because if the bottom is true, then you can say that's also test for convergency. Now, one thing I will mention here is true. So we'll cross this out. We'll cross it out. Please don't have misunderstanding. You know how like sometimes people says all square are rhombus, but not all rhombus are square. Okay, so this basically do not believe this part. Now, what you can believe is this. What you can believe is this. This is what you can sum up to be. If n equal to 1, if a to the n is converge, then limits n approach infinity of a to n has to equal to 0. Not the other way around.
True though?
No, if this is true, so if it's true, then limit n approach infinity a n equal to 0. But you cannot say the other way around. You cannot say if limit n approach infinity n equal to a n equal to 0, then a to n converge. Now I'm going to give you a classical example. you're gonna be like, what would be the classic example? Classic example is, what if an is equal to 1 over n? If anything else, this is the easiest point on the test.
Maybe that's for the conversion.
Yeah. We ask, no, this is sequence. What about series, right? What is series of like n equal to 1 to infinity of 1 over n? So what is this? Well, this is known as, no, it's not 1. I will show you the first few terms. So if I plug in 1, it's this, right? Plus 1/2, plus 1/3, plus 1/4, plus 1/5, plus 1/5, 1/6. So this is a very well known. On my exam, I literally just asked you this particular series. There is a name for this series. It's called harmonic. Harmonic series is diverge. And I cannot prove to you they are diverge as of right now, because I don't have the tool to prove you diverge.
Don't we have the diverge test?
Yeah, but if you look at the diverge test, if limit n approach infinity of 1 over n is equal to 0. But it's equal to 0, does that mean converge or diverge? No, it never says anything. Because you look at a statement, look at something, if it's not equal to 0, it's diverge. But if it's equal to 0, it cannot be switched. This cannot switch, right? This can switch. It has to be a to the n converge, the series converge, then the sequence has to be equal to 0. But if sequence equal to 0 does not mean series converge. A lot of people get lost on that. Who's lost? No? Okay. Are you sure? Okay. Clear? You're lost?
No.
No? You can understand? Okay. So harmonic series, just have to know this is true. As to what I told you right now, I'm not gonna lie to you. You're gonna have to put a faith onto me, says this is true. Now I'm gonna explain that in a second, why that's true. Okay, why that's true. So on your today's homework, it could be like this, right? Hey, summation of n over 2n plus 3, n equal to 1, infinity. Is this series converge or diverge? Joshua, what do you think?
Maybe converge.
Did you do the test?
Yeah, I did not.
You should. Because if I have f of n equal to n over 2n plus 3, let's say this is a to the n, right? And let's do limit n approach infinity of n over 2n plus 3. And if you divide it by highest degree, guess what? Limit n approach infinity n over n and 2n over n plus 3. This is equal to 1/2, right? If it's equal to 1/2, it's what? Diverge. And this is how much work you have to show. I used n-term. So I can... Yeah, you do, but they're gonna go 0. I'm sorry, my fault. Is that okay? Now, I'll give you some example question. N equal to 1 infinity of 4 times negative 0.15 to the n. Is it diverge or converge? Diverge or converge? Why?
It's greater than.
That's greater than 1. It's greater than absolute.
The absolute value r is greater than 1, then it's diverge. And that's all you have to write. Because you provide me the proof. You provide me the proof. So this is like a summation of a times r to the n, right? So, by the way, this is n equal to 0. So this is n equal to 0. So this is one out of definition, sorry. So that's doesn't matter. The r is greater than 1 is automatic diverge. So this is an easy way to test diverge. So on your homework, you look at the r. You look at a n-term divergence test. Are we good? How about what do you think about this one? Summation of n equal to 1 infinity n factorial over 2 2n factorial plus 1.
Is that N1? What is that talking? N factorial or just
Is that converge or diverge?
Would it be a converge? You take it to that.
Is it? Can I divide by n factorial top and bottom? Why not? What will happen here? What will happen here? What will happen here? 1 over 2. So it's 1 over 2 converge or diverge?
Oh, I need to.
Yeah, it's not 0. Why is it converge? It's diverge.
Oh yeah, yeah, yeah.
What?
Yeah, so the top one is also divergent. One half is also divergent.
Oh, yes. Yes. So yeah, but I think use then are you still using an term divergent test or not?
Yeah.
Okay.
The series is adding.
Okay. Okay, Brendan, can you put a damn phone away? Okay. So now that we know, we're gonna show you a borderline cases, which is this cases right here. What happened to harmonic, right? What happened to harmonic, right? So why is harmonic diverge? And we're gonna show you this part. Why is that diverge? So we're gonna study of this an equal to 1 over n. But we're gonna study with two different ways. I'm gonna show you two different ways to approach it. But just immediately, I'm gonna show you that this particular series, that's the summation of n equal to 1 to infinity of 1 over n, we know its harmonic is diverge. And not only that this is diverge, it's actually the borderline diverge. And I'm gonna say that borderline diverge. This is my own interpretation, but I don't believe like so borderline B-O-U-R, right? B-O-R D-E-R. Okay, borderline. Well, what I mean by borderline is this, and I like that Joshua mentioned that the area under the curve. So we don't even care about anything. We care about x equal to 1. So we care about integral from here, the blue line, all the way to infinite. If a blue line all the way to infinite, this is a borderline. This will be exactly diverge. So if you have line above that, is that diverge or converge? If your line that is above this red line, it's also diverge. Why?
Because there's more area under the curve.
More than diverge, right? If you are more than diverge, then it has to be diverge, right?
Because this is borderline diverge. So okay, 1 over x is.
So I will show you that 1 over what? 1 over x to the 0.99. Okay, it's 0.99. So this like look almost the same, right? But look, zoom in a little bit.
Goodness gracious, I see it's doing it.
So the red line is diverged. Therefore, green line has to be what? Diverge, because it has a bigger area than 1 over x. Now, how do you create converge? Is 1 over x to the 1.01. Good. To the 1.01. So now the purple line is less than red line. But the red line is a borderline, right? That anything above that red line, including the line, is diverged. Anything below that is going to be converged. Is that okay? So the first line here, the middle line is the borderline. That is diverged. The green line has more area under the curve than the red line. Therefore, it's also diverged. The purple line has less area than the red line. And since the red line is a borderline, so that means the purple line has less area than a borderline divergence, so that has to be converged. Yes.
Wait, so how do we like why?
Ah, good.
I don't really get why.
Yeah. So that's why a lot of people have a lot of questions generated. So, and I appreciate that because we're gonna introduce you a few tests. The next test we're gonna do is called integral test. Well, what is the integral test? The problem of a sequence series, a lot of people will struggle, is there is a multiple way to approach the same problem. Multiple way. And the thing is that you had to pick the most efficient way. So that's what makes hard. It's not like algebra or geometry, they are very concrete. This is very abstract. So you have to figure out, well, what's the best way to approach it? So, so integral test, what's the integral test? Okay, so that's what I'm going to talk about. The condition for you to do integral test. They say if f is positive, continuous, and decreasing. So you must fill 3 conditions. The 3 condition is positive, continuous, and decreasing. And continuous is between 1 to infinity, usually, and decreasing from 1 to infinity, and positive is 1 to infinity, usually, right? We're going to talk about usually. Why is that important? So for x greater than 1, greater than or equal to 1, and that's why we have the absolute value of 1 to infinity. And an is equal to f of n. Then summation of n equal to 1, this and this either both converge or both diverge. So either they both converge or they both diverge. So you say, okay, what does that mean? So we're gonna give you the classic example, harmonic series. So an equal to 1 over n, summation of 1 over n equal to 1 to infinity. And that's equal to 1 plus 1/2 plus 1/3 plus 1/4. And this one, you say, okay, well, this just means f of n is equal to 1 over n, right? If I use, if use divergent test, is that diverge or converge? Is that, it doesn't tell you answers because limit n approach infinity of 1 over n is equal to 0. But equal to 0 does not mean converge or diverge. If it's equal to any other number than 0, it's for sure diverge. But if equal to 0, it doesn't do anything. So this one is a failed test. Failed test. Why? Because it's equal to 0. That doesn't tell me anything. Inconclusive. Is that okay? Am I going too fast? No, let's do integral. 1 to infinity. And we're going to use x dx. Now, before you use integral test, you must be what? What's the 3 condition? Positive, continuous, and decreasing. We're going to test them. Okay? Is 1 over x positive? Yeah, because start from 1, 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. This is positive. If x is greater than 1. Is that okay? Is this continuous? It's only not continuous, so this is continuous when x is greater than 1 because only not continuous when x equals 0. Is that okay? Is 1 over x decreasing? Yeah, because the graph is 1 over 2, 1 over 3, 1 over 4, 1 over 5, right? You can also use derivative to find out are they decreasing. Right? So what's derivative of 1 over x? X to the negative 1. And the y prime is x to the negative 2 negative, right? Now, start from 1. This is all negative, so it's decreasing. So we fulfill 3 conditions. So what we can do is we can do a limit as b approach infinity. And this is b to 1. Does that look like an improper integral? And what's integration of 1 over x? So it'd be ln of b, right? Minus ln 1, right? What's ln b minus ln 1? Well, ln of infinity. What's ln of infinity? Infinity. So if this diverge, integral test is diverge, therefore what? Summation of n equal to 1, infinity 1 over n is also diverge. So you have to show me the proof why they are diverge. Are we good? We're going to give you 2 questions. The first question looks like this. So this is called integral test. And also do this. If I were you, I'll go back to restarting the notes. Can n-term divergence test prove their divergency on any of those cases? What? No, because if you're n approaching infinity, both cases go to 0, right?
Yeah.
So divergence test cannot prove anything. So sometimes a test fail. Like remember you taking AP Chem last year? That sometimes you can do a flame test on something. And if you do a flame test, sometimes the flame just like regular flame. But if a flame come out green is what? What is present? Copper. It's copper. Copper is gonna show green, and that's why most of firework has copper in there, because there's a lot of green color. Okay? There was sodium is like a bright orange, I think.
Yeah.
And potassium is like a purple.
Yeah.
Yeah. So there was a lot of different tests. But sometimes those tests is inconclusive. You cannot tell what kind of test is that. Especially when you go to UF, they give you a unknown. They ask you, says, hey, find an unknown. And you had to do 10 different tests. You had to do chloride test, nitrate test. You had to do a flame test. So right here, we do the divergence test. We find out both of them are inconclusive. Now, first of all, is this a positive?
Yeah.
Is this continuous function? Okay, so what's the best way to remember those three conditions? COVID, positive, die. Okay, so if you got COVID, you get positive, you die. So for what is it? Is example here is continuous, positive, and decreasing. Okay, so I'm just kind of think of something that's easy. So is this positive? N over n squared plus 1 when n is greater than 1? Is it positive or not? Is it positive, right? If n over n squared plus 1 continuous, yeah, there's only an asymptote at nothing. There's no asymptote because the bottom never equal to 0. Is n over n squared plus 1 decreasing? How do I know that? Oh, not necessary. So not only plug in the value, what's two ways to prove they're decreasing? Derivative, right. So we can say, let's take a derivative. Let's take a derivative. What's a derivative? Low d high minus high d low over low. So that becomes negative x squared plus 1 over x squared plus 1 squared, right? If I do a number line test of x squared plus 1 squared, that's always positive. But I don't need to test anything less than 1. I need to test here, positive. If I do negative x squared plus 1, it's always what? It's always negative, so it's negative, right? So therefore, it's decreasing. So then we say, okay, well, I'm going to do integral tests. So be x over x squared plus 1 between 1 to infinity dx. Is that okay? What would do? How would I take integral of this? U is equal to what? Okay, du is equal to 2x dx, right? Du over 2x dx. So that's the integration of b1 x u du over 2x. Cancel out is 1/2. Actually is 2 over u. 2 over b, right? B is still going to go to infinity.
You can just put it back in as.
Yeah, you can put it back in as x. So it'll be ln of u. So it'll be 1/2 ln of, actually, if I plug in b, this is b plus 1, right? Ln of b plus 1 minus ln of 2.
Just keep it.
Is that okay? So this one's ln of infinity times half. Minus ln of 2. Does ln of 2 significant enough to change anything? No, this is a 1. This is diverge. So therefore, this series diverge as well.
Where did you get the b plus 1?
What?
Where did you get the bound b plus 1 and 2?
I plug in the upper bound, so I plug in the b squared plus 1. Actually, it's b squared plus 1. Okay, ln of 2 is insignificant, right? Compared to ln of infinity. So this one is the only one that counts. 1/2 ln of infinity. And whatever 1/2 ln of infinity is infinity, so therefore it's diverge. Okay. So if you do it quickly, I don't have much time, but if you do it quickly, what does that end up to be? Is this a positive? Is this a converge? It's continuous? Is this decreasing? Yes. So three things is. So can I do integral between 1 to infinity of 1 over n squared plus 1? So what do you think the answer is? So arctan of b, right? Minus arctan of what? 1, right? So this one's going to be pi over 2 minus pi over 4. That's equal to what? Tangent has a asymptote here at pi over 2. And this is very important. That's why I say arctan is one of the most important integral for BC. You have to know all the arctan. Is this okay? Okay. Next. How much time I have? Oh, that's good enough.
17.
This one's super easy. This one my favorite one. My favorite one is makes easy because I don't like complex stuff. Okay, this one's so easy that I think I can tell like a third grader how to do it. They will figure out how to do it. So all you gotta do is if you have 1 over n to the p, not 1 over n to the p plus 1, but just only 1 over n to the p. And so this one is this. It doesn't have a condition, just the condition. This is the only conditions. So if a p is greater than 1, converge. If between 0 to p to 1, this is diverge. So if p is between 0 to 1, it diverge. If p is greater than 1, converge. And this is why this is my favorite series, because this is the easiest one to test. Remember, a to the n equal to 1 over n. Remember harmonic? This is what? 1 over n. P is what? Less equal to 1, right? So this is diverge. And that's how you have to write down. P is less equal to 1. Since equal to 1 is a diverge. That's it. That's how you have to write. P series is my favorite series. It should be everybody's favorite series here as well. Now this is diverge. Very easy, right?
What is on top of the n at the bottom? But when it's 0.99 and less, or so it's
1 or less.
it shifts up, and then when it's 1 or more, it shifts down.
Yeah. So that's what happened to 1 over, let's just say, n squared. Is that diverge or converge? Huh? Converge, because p is greater than 1. Converge. How about this? 3x n squared. Is that diverge or converge? Why is it diverge? This is 1 over n to the 2 over 3, right? And 2 over 3 is what? P is less than or equal to 1. So therefore diverge. It's so easy. I give you 3 examples right here that you can tell right away they are diverge. So let's look at this. Let's look at this, okay? Let's look at this graph again. Look at here. Let's say P series is true. 1 over x is a red line. That's harmonic. We know harmonic is what? Borderline diverge. So it's diverge, right? So do not tell AP exam borderline diverge. Borderline just my interpretation. And I hope you understand that. So if you look at here, the red line is a diverge, but green line has to be diverge because green line has more area under the curve than the red line. Does that make sense? So if the red line's already diverge and the area of the green line is more, so therefore diverge. Look at this. The green line's x to the 0.99. Is that okay? Now, what happened to x to 1.01? Well, 1.01 is less than the borderline. Diverge. So in this case, this is convergent now because this is the last line to be diverged right here. The red line is the last line to be diverged. But if you have more than 1, which is 1.01, and matter of fact, you guys should try to do improper integral of x to the 1.01. And you're going to see what happened there. It's not hard. It's really easy. It's good? Be good. Okay.
So is it absolute value of p greater than 1?
Usually p is absolute. If it's a negative, right, it'll flip, right? So let's just say 1 over 2 to the negative p, that will become 2 to the p. If it's 2 to the p, that has to be diverged. because that's geometric series, right? So it usually doesn't have negative p. No, but you have to use a different part. If I use p is negative, so 1 over 2 to the p negative p, then you should be 2 to the p, and 2 to the p should be a geometric series rather than p series, because this one has to be 1 over n to the p. Okay. Now, Gabby on the previous period says, "Hey, Mr. Ye, can you go back to this question and talk about this?" Shh. Gabby Steffler from 4th period says, she asked a phenomenal question. She asked me, says, "Hey, Mr. Ye, can I use p series on this particular one here? Can I use p series?" It has the plus 1. So let me building something for the future. You cannot use p series, but at the same time, you have to use p series.
It's like some Shakespeare.
Sounds like you're trying to master the movie, right?
To kill or not to kill? So to be or not to be? Okay, I never read Shakespeare. I think I fall asleep on everything on Shakespeare. We are twins. Okay. Shh. Last thing I want to talk about here, guys. This is very easy to understand. Believe it or not. The next test you're gonna learn, which is we haven't learned that right now, but we're gonna show you the next test we're gonna learn is called comparison test. You compare one series to the other series. Hold on. 1 over n squared plus 1 is greater than or less than 1 over n squared. Less than, right? So if it's less than converge, that means what? It's converged. Thank you. And then look at this. Look at this line here. 1 over x squared plus 1. Look at the black line. The black line is way lower than the red line, so it's a converge. Right.
Oh no. You and I both probably never wrote the graph.
Green wall? You gonna wear the green wall to start? It's funny like how SGA just come to this classroom has the most people here. It hit all the people one stop. Yeah, it's like easy start. I was kind of pissed, but that's okay.
Well, what it means is since Asian won that, it means he was shocked. Doesn't mean he's not still shocked.
Look, they're freshman year.
What's the biggest glowing board?
Biggest blow up?
What? Yeah.
It means he was ugly and then he's not ugly.
He's still ugly.
Yeah, what the fuck?
What do you mean?
Bye, Mr. Ye.
What do you mean?
Not as ugly as I was before.
Oh my goodness.
It looks like a chord. Try to check support. 2024. Okay.
2020 from?
I think it's funny. Well, what about that backflip though? Shut it up.
What happened?
What do you think you got on the test yesterday?
Oh, that one?
Exactly the same as homework. I don't know how can you mess up if you
Bro,
mess up.
Rockford's still finding a way to mess it up.
Bruh, nah. I might have forgot to put amplitude.
I don't know you. Lacrosse? Are you in lacrosse?
Yeah.
Oh, okay. I didn't know you're athletic. That's pretty cool.
Oh, is that why everyone's wearing them shirts?
Yeah, I know they're so bad. The jerseys are like 20 years old. Like,
This jersey is 20 years old.
I want to actually know how old it
Yeah,
is,
it's almost
but
like
it's not. It's really. It's got like the old logo on it.
I know. It's like,
Yeah.
Okay, is that your dad also?
Yeah.
Is he white?
Yeah.
I know you're Hispanic.
wait, it's Italian.
You're white? You're Italian?
Yeah.
But you look kind of Hispanic, not gonna lie.
Yeah.
He does.
I
Oh,
get
I
it.
thought it was his dad.
He's
No,
also
when I
Italian.
see you and your dad, I was like, why is the dad's white?
What are you talking about? You're just white?
Oh yeah, I'm Italian.
Oh, no, you're not white, you're
No,
not.
I didn't say I wasn't.
You gotta get one out.
Yay.
We're talking between me.
Where even is that? I don't know what that is.
It's like, probably from like, sequel from like.
Cool.
That's the wonderful.
I was never American.
Oh, remember the
What?
Ow!
No way, boy.
Took the
Guess what? I did too.
Please get away from me. Get away from me. Get away.
Cole, leave her alone.
Thank you.
Oh.
That's harassment.
No.
They said.
Yeah. What's your favorite water? Yeah. What? What is that? Oh! I got it. What's your favorite gun?
I spoke too much in alcohol, so she was in higher class.
What?
Okay, so Elton did that whenever I
No, he told him to shut up like 6 times. She didn't shut up at all.
my
I got
master
moved
plan.
because of him.
My master plan. I got to sit with all my friends.
Yes, it's such bullshit. She moved me away from everyone I know, and then she put him with all his friends. We cannot be dead serious. You get the craziest bias all around. That's so bullshit.
Are you saying
All right. Shh. I have 2 people here and take it. You want to take it now or after school?
Take it right now.
Now? Okay, Devin, you want to take it now or after school? Okay, we're covering new stuff. You're gonna miss the new stuff. I don't know. Sometimes it's not on it,
Sometimes it doesn't pop up on the YouTube either.
but sometimes my YouTube is gonna show us something.
I got work at like 3:30. I gotta leave at 3:30 to get at work at 4.
I would suggest you take that. All right. Shh. All right. So some of you guys need to understand that you're supposed to know how to take you're supposed to know how to graph sine and cosine now. And I'm gonna talk about tangent and cotangent today, and I'm also gonna talk back to sine and cosine again. So and one of the questions is the FRQ on the pre-calculus, so which is kind of important. So we're gonna go into to do those stuff. So and luckily we talk about tangent graph because in the math competition actually all the student, we are the first one to get the slide. Yeah, all 20 points. Okay, so because we know what a tangent graph look like, and so we want to review a little bit about tangent graph.